What if I tell you this tiny microcontroller can blink an LED, read a sensor, and send UART messages at the same time without multiple CPU? Today, you will finally understand how FreeRTOS multitasking really works, and by the end of this video, you will be able to write your own FreeRTOS task based on program. So, this is day 2 of our RTOS beginner series. Let's go. Hello engineers, welcome back to the e-learning where embedded system becomes simple. In day 1, we learn what RTOS and why embedded system need it. Today, we go deeper in task, multitasking and the scheduler, the heart of any RTOS. In the day 1, we learn why normal while loop programs become messy, what RTOS really means, why FreeRTOS is used in real system. If you haven't watched this video, please go into the description box. I'll give you the link for day 1 video. So let's start with basic question. What is task in FreeRTOS? A task is just a function but with superpowers. In bare metal programming, we usually write one big while loop. Inside that, we call LED blink, sensor, communication, every one by one. But in FreeRTOS, each of these jobs becomes its own task. So, think of your microcontroller as a single office worker. So, this is your single office worker. Without RTOS, the worker does only one job, then moves to the next. With RTOS, every job gets a time slot, emails, phone calls, printing, and meetings. The worker switches so fast it feels parallel. So, the task will switch from one task to another, from LED to sensor or sensor to UART. So, remember this, task equal to independent function, has its own stack and has its own priority and controlled by scheduler. So, why multitasking is needed? Let me show you a typical problem. Suppose you write a code like this. Now, what if read sensor takes 500 milliseconds? Everything else wait. LED freeze, UART stop, system becomes slow. This is called blocking. So, have you ever seen your LED stop blinking when UART printing happens? That's exactly what RTOS exists. With RTOS, each job runs as a separate task. LED task, sensor task, UART task. Even if sensor is slow, LED blink. Now, here comes the fun. Your microcontroller still has only one CPU. So how does RTOS run multiple tasks? FreeRTOS rapidly switches between tasks. So if this task is executing, it will rapidly switching with sensor task, rapidly switching with UART task. It saves the CPU register of task A. Load task B. Run it for a few milliseconds, then switch again. This is called context switching. This switching is triggered by hardware timer called the SysTick timer. Every tick interrupt scheduler gets controlled. So imagine flipping TV channels very fast. You think all channels are playing, but only one is actually shown at a time. So we'll go to the scheduler. The scheduler is the main brain of RTOS. It decides which task runs now, which task runs next, how long each runs, priority handling. So think of the scheduler is like a traffic policeman. Tasks are cars. High priority ambulance goes first, normal car waits. So consider this is policeman which decide which task we need to execute first. If this is ambulance, this can be go first. This can be executed first because it has high priority. Every task can be in one of these states. So we have task states. Ready state means waiting for CPU. Running state means it's executing. Block state means waiting for delay, and suspended state means the execution is stopped. We will see live real-time demo example. We can create one example system. It's read the sensor input, it control the LED, and it will transmit data on UART. So let's consider LED blink task will run every 500 millisecond, sensor read task will run every 1 second, and UART will run or print every 2 seconds. So task 1, here I created 3 tasks. Notice each task is just a function with infinite loop. Here you can see this is one task which create one infinite loop. Okay, instead of using delay, we use vtask delays. So this is our RTOS delays, which tells us how much time it will take. It is 500 millisecond, 1000 millisecond, and 2000 millisecond. So sensor task has priority 2. So whenever it becomes ready, scheduler run first. So here you can see the priority for LED task, priority for sensor task, and priority for UART task. So for UART and LED we given priority 1, and for sensor we give priority 2 because this is higher priority task. Now look at the output. LED toggles every half second, sensor prints every 1 second, and UART prints every 2 seconds. They are not blocking each other. That's multitasking. So let's summarize day 2. Task equal to independent program. Multitasking works by context switching. Scheduler is the traffic controller, and priority decide importance. vtask delay makes corporate multitasking. So in day 3 we will learn how task communicates, queues, semaphores, mutex. That's where RTOS become powerful. If this helpful you, like the video, subscribe for the full RTOS playlist, and comment task below. See you tomorrow, engineers. Thank you. Thanks for watching.